should have the easier gain adjustments. Not only the finite and the stable gain is required, but a variable gain over the described range is also. Okay, it should have the stable gain, finite gain, and even the variable gain. The gain adjustment must be easier and precise. It is again the requirement. Instrumentation amplifier should have high input impedance. It is required to avoid the loading of the input sources, and the instrumentation amplifier should not draw any current from the input sources. Input impedance should be high, but output impedance should be very low. Okay. It should have very high CMRR. It is required to amplify the differential input and rejecting the common mode signals and rejecting the noise, etc. Okay. The power consumption should be low. The amplifier parameters should not change with the thermal and the time. Due to heat and time, there should not be any drifting of the parameters of the instrumentation amplifier. So should not have drift with temperature or time. For the faithful reproduction, the slew rate should be very high of the instrumentation amplifier. The operational amplifier or instrumentation amplifier should have the two different inputs. If the input becomes equal, then the instrumentation amplifier will give a 0. So there should be some differential signal at the input. Instrumentation amplifier measures physical quantities like temperature, humidity, water, flow, etc. by transducers. But the output of the transducer is quite low and it is enhanced by the instrumentation amplifier. Okay. So this is an instrumentation amplifier with the transducer bridge. This is a bridge circuit and the voltage is given to the bridge. The bridge is balanced. So that's why at the two terminals there is no voltage, and no voltage means no output. This is a variable resistor. Its resistance changes with the physical parameters which we have to measure. When the resistance changes, there comes a change in the differential input. Now the differential inputs are not equal. They become unequal, and when the differential inputs are unequal, then instrumentation amplifier will give output. That output now will drive the display units. Okay. Instrumentation amplifier using only one operational amplifier. The other two inputs, this is an op amplifier, inverting and non-inverting. This is an output. This is a feedback resistor, R1, R2, and to non-inverting, R3 and R4. R4 is grounded. There are two inputs, V in1, V in2. Okay. This amplifier is basically a differential amplifier made up with inverting op and non-inverting op. So differential amplifier is the sum of inverting and non-inverting operational amplifier. As explained now we're going to explain how it is made up of inverting and non-inverting op. Let if V in2 is grounded, there is no input at the non-inverting terminal, then this op becomes inverting operational amplifier. If V in2 is grounded, then it acts as the inverting operational amplifier. It acts as inverting operational amplifier, and we know the well that what is the output of the inverting op? It is equals to minus R2 over R1 into V in 1. This is the result if V into is grounded. Let we think other way around, that V in 1 is grounded. Then it acts as non-inverting operational amplifier because input is at V in 2, which is the non-inverting terminal. So let's find the current flowing here. Current is voltage divided by the resistance. So this is the current flowing. Now voltage at this point. Voltage is equals to current into R4. This voltage is applied to the non-inverting terminal. The result of non-inverting op is the output voltage equals to 1 plus R2 over R1 bracket into voltage at the plus terminal. 1 plus R2 over R1 R4 upon R3 plus R4 into V in 2. This is the output of non-inverting op. Now the differential amplifier is the sum of inverting and non-inverting, and we have found the result of output voltage of inverting and non-inverting. So taking the sum of the two, inverting plus non-inverting output, in addition adding the two, this becomes output voltage. Rest part is only the simplification with the assumption R1 equals to R3 and R2 equals to R4.
then the above equation, the above output modifies too. This result of differential amplifier, you can see instrumentation amplifier using one op. So this instrumentation amplifier gives us output. It gives us output V0, which is amplified by R2 over R1 to the differential signal. So output is differential input multiplied by R2 over R1. So it is having all the characteristics. This instrumentation amplifier having the characteristics which are required for instrumentation.